I wanted to give one of these a go. This is the Taramps Smart Charger, 200 amp power supply, 280 dynamic. So all of the Brazilian brands do one of these. You've got the Paris do one, Taramps do one, and Stetson do one. You've seen them. There's a Ucina as well. And they're all very similar inside. But this one claims to be a smart charger, so you can hook it up to lithium and basically forget it and just let it do its thing. It will look after battery banks much better than just a dead power supply, just a power supply will do. They're just dumping current into them. So I wanted to see what this was all about. But turns out it wasn't so great, because initially when I got this and plugged it into my mains, the second that I hit the switch, it tripped the breaker in my house on 2 units. I got another one here. So the reason for that turns out to be that the way Taramps have designed this is that we have, so I've done a modification here, just forget this, but Taramps have designed this where mains comes in and mains voltage gets rectified by this full bridge rectifier, and then after it's been rectified, the DC just goes into these caps. And obviously when these caps are empty, they present a near dead short to the mains through the rectifier. So when I was plugging this in and hitting the switch, it was drawing a immense spike of current to charge these empty capacitors through the bridge rectifier. And in Brazil, that's not a problem, and in other places in the world, that's not a problem. With the lower voltage, it can accept higher pulse current, higher sort of transient currents. But in the UK, the breakers that we use are a little bit more sensitive, and with the 240 volts, the current threshold is less. So it was tripping the breaker every time. And unfortunately, when it tripped the breaker one time, that kind of spike of going on and off and tripping the breaker actually killed the MCU on this one here. So I've had to repair that, and also it killed the little screen underneath here. So that's why this one's kind of in pieces. But I thought you guys might be interested to see just a quick, very basic, very redneck modification that I've done to both of these now, so that they can work here in the UK and also other places in the world. And it's just better to not like massively current spike your bloody mains when you plug it in. All I've done is I've got a relay, which you can find in pretty much any like Korean car amplifier. These are rated for, I think it's like 20 amps, or no, sorry, these are rated for 30 amps. So a 30 amp relay with the coil energizing on 12 volts. And what we do is the mains comes in here and it sits on the contacts that are currently open, but it does trickle through via these resistors. I think this is like 300 ohms of series, a couple of resistors together. So basically the circuit still gets its power from the mains, but it gets it through a 300 ohm resistor, so that when you plug this into the mains, all these caps are charged through the resistor first, therefore reducing the current on when you plug the mains in. However, obviously we can't have the power going through these resistors when this is up and running. So what I have it set to is when the thing turns on, when you power this up and it comes alive, the 12 volts that's on the output terminals here, when this 12 volts comes alive, it actually energizes the relay coil, closing the relay and therefore making a direct connection to the mains through the relay contact. So that's just a very quick workaround, and it seems to work absolutely brilliantly. The specs of this power supply are within the specs of the relay, and yeah, it just works beautifully. I've also put a little 4148 diode in here to just stop the spiking back from the coiling gauges to the output side here. But yeah, that works really well. I haven't personally done any further testing with these yet. I've bench tested a couple of small amplifiers in the workshop here just to confirm it works, and it does work fine. But I might plan some content with this, or just use it in my live streams for bench testing amplifiers after they've been repaired. But I thought you guys might like to see this on my little clips channel, just to kind of see what they look like inside and see the modifications I had to make to actually get them to work here in the UK. I was kind of unhappy. This is a very poor design. The Paris power supply does actually have soft charging, soft start built in, but the Taramps literally has empty capacitors connected straight to the mains through a full bridge rectifier. And yeah, when you flick the switch on, if the breaker doesn't trip, the lights like dim. They go boom, the lights all dim for a split second. So I thought that was kind of crazy and kind of whack, but there you go. Apart from that, it's pretty well assembled. Everything's seated down really well. You've got 2 different MCUs. You've got an MCU over here and an MCU over here. Fortunately, Taramps are very good at supplying new MCUs if these do fail for any reason. Not that many semiconductor components, but we've got 200 amps or 280 amps peak. So this isn't the most powerful Brazilian sort of power supply. There are ones that are higher current and that can do higher pulse dynamic current, but yet to test out the battery charging capabilities, but I'll be doing that pretty soon, I think. So stay tuned for that.